Hello. So in the previous session, we explained how to approximate, how to round a given number up to a certain place. Okay, the place can be a place on the whole part of this number, or can be placed in decimal part. Okay, decimal place like. So we started by why we approximate the value of the digit, and we continued to explain the rounding process, how to round to whole part places, and how to round to decimal places. Okay, so was very easy to find this one. So we have the second part is about significant figures. When we know what we mean by significant figures, so all the rest is very easy, will be very easy. Okay, so what do I mean by the significant figures? So all digits are not a zero or significant figures. Normally, be any number in any number, given number, real number, okay, with a decimal point, without decimal point. So all non-zero digits are considered as significant figures. Okay. So first, we should read the rate of this first significant figure from left to right, like this arrow here. Okay, we have this number. How to find the first significant figure? So 3 is not a zero. Okay, not a zero. So it is a first significant figure, second significant figure, third significant figures, and 0 as a fourth significant figures. So the first significant figure in a number is the first digit that is not 0. So we have here a condition when we read the number from left to right. The first digit should be not a 0. So if the number start with 0, okay, 0, 3, 7, 9, and 0. So this 0 is for us useless. Okay, it is not a significant figures. But if we have a 0 inside between two digits, okay, the 0 inside, it is a significant figures. The 0 which is on the right after zeros, after a digit which is not a 0, is a significant figures. So the condition is to start to enumerate the significant figures from left to right with a digit which is not equal to 0. Okay, so 0 between non-zero digits are significant. Very good. 0 at the end may and may not be a significant. May and may not. يمكن كلها. Okay, so we will continue. So in this example, so 0, 0, we start to read from left to right. So not significant, not insignificant. The first significant figures is 7. Okay, and let's continue. Complete the following to round to 8. So we start the same idea, the same rounding process, but using the expression significant figures. Okay, like complete the following number to round this number. Okay, correct to the given level of accuracy. The first significant figure is, which is the first significant? We start to read it from left to right. So the first significant figures, 2 is not a 0, so it is the first significant figures. Okay, which is in the tens column. Because we have here the decimal point. So is the unit column the tens column. Tens column, so we round this number to the nearest tens. Okay, to the nearest tens. So we compare to the digit on the right, which is 8. 8 is bigger than 5, bigger than 5. So we add 1 to the number which is in the digit tens. Okay, we add 1 to 2, and we replace 0 all along on the right of this number. So we obtain 30.0000, which is mean 30. Okay, so 28.47058, it is rounded to 30, correct to the one significant figure. Okay, the second significant figure is normally is 8. Okay, first one, second one. Okay, 8, which is in the units column. So we round it to the nearest one. So to the nearest unit, we mean by that. So we compare the digit which is on the right. So which is in the first place, decimal place, which is 4. 4 is smaller. 4 it is smaller than 5. So we add nothing to 8. So to 28, and we replace all the digits on the right by zeros. So we obtain 28, correct to the second significant figure. Okay, and we can complete all around. And for example, the fifth significant figure is okay, we'll complete it. Okay, together. So the fifth significant figures is, so first one, second, third, fourth, and fifth. So 0 is the fifth significant figure, which is in the third place, third decimal place. Okay, after the decimal point. So we rounded to thousandths. Okay, to thousandths. So we are here. So we look to the right. 5. 5. We compare it to 5. 5 equal to 5. So we add 1. We add 1 to 47. 1, and we replace all the rest by 0. Okay. So 28.4471 is the correct answer to the given number, to fifth significant figure. Okay, you can remark that a 0 digit between two non-zero digits is considered as significant figures, as we said before. Okay, and you can continue the exercise 3 by yourself. Okay, so so we have here a small idea. So in the exercise 4, for example, J, 999,900. Okay, want to correct it to 3 significant figures. Okay, 3 significant figures. First, we read the significant figures from right to left. So 1, second, and third significant figure. So third significant figure. So we want to correct it or to round it to the nearest thousand. Thousand. Why? Unit, tens, hundreds, thousands. Okay, to the nearest thousands. So we compare the next to the right. So 9. 9 is bigger than 5. So we add 1 here. We use the calculator. We replace all the digits on the right of the thousand column by zeros, like we see here. And we add 1 to 999. We can use the calculator. 999 plus 1, it is equal to 1000. So the rounding, the correct answer of 999,900 to the 3 significant figures is 1 million. Okay, it's very easy, and we can find all the details in this PDF. So when a number was rounded to 2 significant figures, the answer was 430. So we have the answer of the rounding process. but we want to ask about the smallest number that could have been or the largest one. Okay, and we want to write a mathematical statement that shows the range of possible numbers. So be aware, be very smart here. We want to round a given number to two significant figures. So each number we treated alone. We treated alone because the second significant figures in each number is different, as in different places and is in different column, a digit column. Okay, so like 430, the second derivative, the second significant figures is when we read the from left to right is 3. 3 is located in the 10th column. 10th column, we should be rounded. This number should be rounded to the nearest 10. Nearest 10. So let k equal to 10, okay, and the number n equal to 430. So we can say and have a statement, a rule, general rule that n, this number, can be the smallest number could have been n minus k over 2, and the largest smaller than n plus k over 2, because we have here equal, so can be here strictly smaller than n plus k over 2. K 10 over 2, so 5, we add 5 here, or here we subtract by 5. So the smallest one is 425 and the largest 435, or smaller than 435. And in the same way, we treat and we obtain the answer of the second number 3.7, where the second significant part is in the first decimal place. First decimal place, so we should be rounded, the number should be rounded to the nearest 1 over 10, so k equal to 1 over 10. How to say, or how you, so you can easily, after this explanation, you can easily do by yourself the exercise 5, 6, and 7, and in the last idea, state the number of significant figures. So we should give the number of significant figure in each of the following numbers, like 294. We start from right to left. So first, second, third, we have 3 significant figures. However, here 0 is uncountable, so because it is on the left. So 3, so we have 1 significant figure. Here we start by 4, 2, and 0. So with 0 we can count it. So 3 significant figures. Here 0 uncountable, uncountable, uncountable. So we have 1 and 7. So 2 significant figures. Here we can have 2 or 3 or 5 or 4 or 5, because he said before in the first slide that the zeros on the right can be, maybe, or not may be a significant figure. So like we said before, sorry, like zeros at the end of a number may or not may or may not be significant, so we add here or 2, 3, 4, or 5. Okay, thank you for listening. So I'm waiting for any of your question, and bye bye.